Let Px and Qx be polynomial and Qx is not equal to 0. Then Fx defined by their ratio Px over Qx is called a rational function. So a rational function is a ratio of two polynomial functions. Let's talk about asymptotes. We will say line x equals c is vertical asymptote if we are approaching to c from either side, from left hand side or right hand side. Our function is going to either infinity or negative infinity. X equals c is vertical asymptote if we are approaching to c from either side, left hand side or right hand side. Our function is going to infinity. Like if we are approaching to c from right hand side and our fx is going to infinity, c is a vertical asymptote. If x is going to c from right hand side and our fx is going to negative infinity, this way or this way, we will say x equals c is vertical asymptote. If x is going to c from left hand side and fx is going to infinity, or x is going to c from left hand side and fx is going to negative infinity, in these cases we will say x equals c is our vertical asymptote. Looking at the graph and checking vertical asymptotes is fairly easy, but what if we have algebraic form? Then how will you find your vertical asymptote? Very easy to check. We will say x equals c, the line x equals c is vertical asymptote if denominator is 0 if denominator or your bottom is 0 at c but numerator is not 0 at c. Is not 0 at c. Then x equals c is your vertical asymptote. Or you can also say you cancel out all the common factors and then substitute your denominator equal to 0. Let's do some examples. So our first example to start with is fx equals x minus 3 divided by x square minus 4x minus 5. What we will do? Find the points at which your denominator is 0. X square minus 4x minus 5 equals 0. You can use quadratic formula or you can factorize. Which means either x minus 5 is equal to 0 or x plus 1 is equal to 0. Adding 5 both sides, I got x equals 5. Here I got x equals -1. Then you will check if your numerator is 0 on these points or not. At 5, my numerator is not 0. At -1, my numerator is not 0. So you will check 5 minus 3 is not equal to 0. -1 minus 3 is not equal to 0. So x equals 5 and x equals -1. These are your vertical asymptote. So this is one way. Another way you can do is you factorize your denominator, cancel out the common terms, and then find the points at which your denominator is equal to 0. Sorry, x plus 1. This was x plus 1. So x equals -1. And then these are your vertical asymptotes. Okay. Another example, fx equals x minus 3 divided by x square minus 2x minus 3. So you substitute your denominator equal to 0, find those points. So if I factorize, I will get x minus 3 times x plus 1, which means either x minus 3 is equal to 0 or x plus 1 is equal to 0, which gives us x equals 3 or x equals -1. Then we will check if our numerator is 0 on these points or not. So I am putting value of my x in the numerator. At 3 it's 0, so x equals 3. We will call it a hole in the graph, and x equals -1 is your vertical asymptote. So this is one way. You find your denominator equal to 0, you check if the numerator is 0 on that point or not. Or another way or alternate way, is you factor out your denominator, you cancel out any common terms, and then substitute your numerator equal to 0. Sorry, denominator equal to 0. So first you cancel out common terms and then you substitute your denominator equal to 0, and that will give you your vertical asymptote. Let's do one more example. Fx equals -8 divided by x square plus 25. So we put our denominator equal to 0, which means x square is -25. There are no real numbers such that the square is -25. So we'll say in this case we do not have any vertical asymptote, and done.